Welcome to qnawire.
So this problem might seem like we're not given enough information to solve it, because we're just given one sentence and then told to find the velocity. But the key to this problem is the fact that we're told that the satellite is synchronous. Now, that word just means that the satellite is traveling with the same period as the Earth itself. So that means that essentially the satellite is always hovering over the same place on the Earth's surface because it's moving at the same speed that Earth rotates. So what does that mean for us mathematically? Well, Earth's period is 24 hours, right? A day is caused by the Earth's rotation, and that's how long a day lasts. Now, if we want that in seconds, we just multiply by 60 twice, and we find that Earth has a period of 8.64 times 10 to the 4 seconds. Now, from there, we can write down our equation for period. That's 2 pi over omega, the angular velocity, which we can rewrite as 2 pi r over v. All right, so what is v equal to then? Because we're not given that in this problem. Well, we know that for any problem involving a satellite going around the Earth, since that motion is circular, we must have a centripetal force equal to mv squared over r. And the only force that can be causing that centripetal force is the gravitational force. So that is going to be equal to the mass of the satellite times the mass of the Earth times the gravitational constant all over r squared. Remember, we're doing this to find v. And from there, we can cancel out the mass of the satellites, and we can get that v is equal to the square root of r over the gravitational constant times the mass of the Earth. Now we can plug that back in to our equation for period, and we find that t is then equal to 2 pi r all over the square root of r over g me. Now, if we want to now our final goal was actually to find the velocity, right? And clearly the equation for velocity involves our radius, which we don't know in this problem. So we're going to rearrange our equation for t in order to solve for r. And we find that this is then equal to, or that r to the 3/2 is equal to t times the square root of g times mass of the Earth all over 2 pi. And those are all quantities that we know. We just figured out the period, and the gravitational constant and the mass of the Earth are constants given in our textbook. So we can plug in to get 8.64 times 10 to the 4th seconds times the square root of 6.67 times the units for the gravitational constant are weird. It's meters squared over kilograms squared times 5.98 times, let me double check, 10 to the 24. That is the mass of the Earth. And that is going to be all over 2 pi. The mass of the Earth should have units of kilograms, but sadly they do not fit in this edge of the page anymore. But our final answer for r is going to be 4.32 times 10 to the 7 meters. Now, using the equation that we found earlier for v, the square root of r over g times the mass of the Earth, we can now simply plug in order to solve. So v is equal to 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24. I'm leaving out the units right now because you saw them earlier. And all of that over 4.23 times 10 to the 7 meters. And we find that v is equal to 3.071 times 10 cubed meters per second, which is the answer to this question.